Assalamu alaikum, dear friends. Welcome to the lecture of the quantum mechanics. In this lecture, we will discuss the problem for the solution for the problem number 6.4, which says that consider we have an isotropic three-dimensional harmonic oscillator potential for which P of x y z is equal to m over 2 omega square x square plus omega square y is y square plus omega z square. Mean this is an isotropic three-dimensional harmonic oscillator, and we have to evaluate the energy level in terms of omega x, omega y, and omega z. And second, calculate h and lz. Do you expect that the wave function to be eigenfunction of L square? And the third question is this. Okay. In this problem, we are given an isotropic three-dimensional harmonic oscillator, which for which the potential is given is equal to this is equality sign m over 2 omega square and this. The first thing that evaluate the energy level in terms of omega x, omega y, and omega z. In order to solve this, for example, for the one-dimensional harmonic oscillator, we have Hamiltonian, which is along axis, which is given as hx is equal to px square over 2m plus m omega square over 2. This is Hamiltonian for one dimension, and similarly energy corresponding to this Hamiltonian is E n x is equal to this equality sign h cut omega into nx plus 1 over 2. This is for one dimension. Now we have an isotropic three-dimensional harmonic oscillator, and we will use some familiar identities, which is like xi and L commutator, which is equal to Levi-Civita symbols iota h cut and xk, and similarly pilj. These are the identity that we will use while evaluating the commutations of Hamiltonians with other operators. So now we note that our Hamiltonian can be written as, because we have three dimensions, so Hamiltonian will be equal to sum of the total energy. Hamiltonian is sum of the total energy, kinetic plus potential energy. So kinetic energy is p square over 2m plus this is potential, which is given. So potential momentum for the three dimension will be equal to px square plus py square plus pz square over 2m, and potential is given, which is m over 2 omega square x square plus this whole term. So if we write x as a separate and y for separate and z separate, so this will become hx plus hy plus hz. So this was a required solution for which they have asked that write the Hamiltonian as a sum of hx, hy, and z. Then evaluate the energy level in terms of omega x, omega y, and omega z. So energy will be equal to, because we know that the total energy is given by En is equal to Enx plus Eny plus Enz. So if energy for one dimensional harmonic oscillator is equal to E is equal to h cut omega into n plus 1 over 2. So for three dimension, then nx will be equal to h cut omega nx plus half. Similarly for ny, it will be h cut omega y into ny plus 1 over 2 plus h cut. This is for z. So the total energy is E n x y z will be equal to like this. In the second part, we have to show these commutations, which is calculate commutation of h and lz. Do you expect that the wave function to be eigenfunction of L square? Mean if lz and L square have same eigenfunction, so definitely h will be have same eigenfunction. So h and lz commutation of lz. To find the commutator h and lz, we will decompose the Hamiltonian into components, because we know that h consists of two components. The first is hx, hy, and hz. So let's try one by one. So first will be, this is hx plus hy plus hz. So if we commutate, want to find commutation, so first this will goes with this, then hy, lz, and then hz, lz. So hz and lz will be equal to 0. Similarly, let's take a look at it. hx and lz is equal to 0 for hx and lz. We know that commutation of this can be written as px square 2m lz plus its potential. You know that Hamiltonian is equal to px square plus 2m, similarly, and this corresponding potential, and lz. So its commutation will be like px square commutation with this and commutation with these two terms one by one. So the total commutation of these two will be equal to this. Now we know that we can write our associative formula at this term by term. So for this it will be equal to, you know that AB into C will be equal to A into BC plus C into AB. This formula, we will apply this formula on this term, so it will expand like this, and similarly applying that associative formulas on this term, so it will give us for the two terms. Okay, now using the above result, these formulas, this one, so it will give us Px and Lz. Similarly, some term will go to 0 and some term will survive. So we will left with Hx and Lz will be equal to iota h cut Px Py over m plus iota h cut omega square and x into y. This is commutation of Hx and Lz. So by the symmetry, we can write that Hy and Lz will be equal to minus iota h cut Px Py over m plus minus this term. And for the total commutator, mean if we write to find the commutator of H and Lz, so it will be written as Hx plus Hy plus Hz and commutator L. So this will be Hx into Lx, Lz, Hy into Lz and Hz into, then we will definitely sum all of these commutator by putting value from back. This will give us H commutator Lz will be equal to iota h cut omega x square minus omega y square into xy. And the next third part, we are being asked that find the energies. In third part, the statement of the third part is find the three lowest energy level for the case when omega x is equal to omega y, which is equal to 2 by 3 omega z, and determine the degeneracy of each level. So we have to find the lowest energy levels. We know that we are given with the general, we have already found out the general expression for the energy, which was equal to E is equal to h cut omega nx plus 1 over 2 and plus h cut omega ny plus 1 over 2, and these were the that we have obtained in the previous part. And we are given that omega x is equal to omega y, which is equal to 2 by 3 into omega z. Let's call this omega, so it will h cut omega and similarly h cut omega, and this for the omega z it is equal to 2 by 3. So if we multiply this on the other side, so this will become 3 by 2 omega z will become is equal to 3 by 2 and omega. So 3 by 2 h cut omega into nz plus 1 over 2. And then for the ground state, we know that as for the ground sun, nx is equal to 0 and y is equal to 0 and z is equal to 0. So for the ground state, we will be equal to h cut omega 0 plus half, similarly h cut omega into this and this. So we will sum these all the terms, so it will give us 7 over 4 h cut omega. And for the degeneracy, we know that the formula for the degeneracy is g of n is equal to n plus 1. As we know that n is 0 for the ground state, so n will be 0, g will be equal to 1. So degeneracy for the first lowest state will be equal to 1. Similarly, we can find the energy for the first excited state, for which one term will be either nx will be 1, nx will be 1, and y will be 0, and z will be 0, or and y will be 1, this will be 0. Similarly, either of three term, one will be 1 and the other will be 0. So this will give us energy h cut omega into this, and first excited state energy will be equal to 11 by 4 h cut omega over 4, and degeneracy will be equal to n plus 1. So if we n is equal to 1, then 1 plus 1 will be, because we know that n is equal to nx plus ny plus nz. If for example this is 1, these two terms will be 0 for the ground, for the first excited state, so it definitely is n will be equal to 1. If this is 0 and this will be 1 and ny will be n and z will be 0, mean either of the three terms, one will be 1 and other will be 0, so this will n will be equal to 1. So we put this in the generation relation, so it will give us 2. Similarly, for the second excited state, we know that we have 0 0 1, so we can find the energy for this. It will be equal to 13 over 4 h cut omega, and this degeneracy will be equal to 1 again. So these were the requirement of the question. I will stop at this point and we'll meet in the next lecture.